Good morning, Tehmina Khan is here in TKMaths is Fun. In today's video, which is video number 2 on composite function, domain and range. In the first video, we look at the concept with the help of 3 examples that how to state a reason if the composite function is not existing. What are the reasons? So we looked at it. In this question number 2, which has 3 parts, and in this video I will solve all 3 parts and explain all 3 of them. F of g is existing, this is given to you, and you have to find out the composite function domain and range. Now the function g is given to you with its domain x greater than equals to 0. It is a linear function. And function f is a quadratic function and its domain is x belongs to real number. Now we have to find out the domain and range of this composite function f of g of x. Now here you have to remember that g of x is called first function or inner function, and its range will become the domain of f. Or in simple words, when I will substitute this value in function g, the values of y I will get, which is called range, will become the domain for f. So this is what we will do here first of all. So let's substitute the values x greater than 0 in function g. Okay, you can, because it is a linear function, it is one-to-one function. I don't need to do sketching here. I will simply substitute the values here and I will get the values of y, which is called image or range. But I have done sketching here as well to explain it to you. So if you see x is greater than and equals to 0, it means I'm talking about this part of the x value. And for this part of the x value, the graph is this one. So what are the values of y on it? Greater than equals to 2, which is our answer as well. Now this value of g function will become the domain for function f, because it is a second function or outer function. So same thing I have written here. Now g of x greater than equals to 2 is the same domain for f of x. If you see here, what is the domain of f of x is given to you? X belongs to real number. If this condition is satisfied, it means the composite function is existing. We don't have to prove, but we always solve this part, and I will tell you the two methods we will do here to find out the range of the composite function. So if this proves, then we can do the second method as well. If this does not prove, we cannot do the second method. Okay, now let's start here. So we have seen the range of the inner function g, which is the domain of the outer function f now, and it is lying inside the given domain of the outer function. Okay, so now we will write the reason here, and you should know this thing. The domain, just a minute, let me pick up a pen. The domain of the composite function, because you have to find it out, is the same as the domain of the first function, or it lies inside it, right? So in this case, now this is lying totally inside it, right? So we will take domain x greater than equals to 0. F of g of x, domain is x greater than equals to 0. Now we have to find out the range. To get the range of the composite function, we will put g of x greater than equals to 2, which we have found here in part 1, right? So now I will substitute this domain in the outer function, which is f of x, and it is a quadratic function, x square plus 5. Now when it is a quadratic function, you need to be very careful, because sometimes you get the answer correct just by substituting the value of x in it, and sometimes not. And we will see the reason here why. First of all, I substituted the value x2 in function f, and my answer is coming 9. So now I will see either this will be the range of my composite function or not, right? So let's see here. For that, you need to have an image of the sketch. If you cannot visualize, you can draw it here. So function f is x square plus 5. And this is the sketch I have given to you here. The turning point is 0, 5. When I'm talking about the values of x greater than 2, it means this corresponding value of the turning point x is not lying within this given domain. So, if I see x greater than equals to 2, I'm talking about this part of the curve, which is 1-to-1 function. So when it is 1-to-1 function, you can simply substitute the value and get it from substitution. So I got 9. It means for x greater than equals to 2, the values of y will be greater than equals to 9. So that's why I will say the range of the composite function is greater than equals to 9. And what is the second method? Second method is I straight away find out the composite function first of all, which is f of g. So g was 2 plus 3x, right? This will be my domain for function f. So I have found here my composite function f of g of x. Now in this function, I will substitute the values of x of the inner function, x greater than equals to 0, right? Now when I substitute x greater than equals to 0 in my composite function, what is the value of y I'm getting? 9. And why did I use greater than equals to? Because of the concept of a sketch I have. If I sketch this curve, composite function here, right? My turning point is now minus 2 upon 3 and 5. You can see it here. So for x greater than 0, the values of y are greater than equals to 9. So this is the second method, and that is only you will do if you prove that the composite function is existing. Okay, we have seen that in the first part. Now let's see question number 2. Exactly same, but these 3 questions will help you to retain the concept in your mind. Nothing new, exactly same as example 1. So if you have little confusion, example 1, this will help you further understand the concept. Okay, so now again we have to find the domain and range of f of g of x. G of x is my inner function. For the inner function, the domain given to you is x less than 2. Right? And this is a quadratic function now. I have to find out its range. Okay? So, what did I do? I did this sketching here for you. Let me explain it to you. This is the sketch of x minus 2 whole square plus 1. So, turning point is 2, 1. Sorry, I should write here. Just a minute. 2. And domain is x less than 2. It means I'm talking about this part of the x-axis, which means I'm talking about this part of the curve. It's not very neat, but good to understand. What are the values of y on it? The values of y on it are greater than 1. I will not use the word equals to because with 2 there is no equal to. So this is my range of function g. And now this will become the domain of function f, right? You know this basic concept. So I've written the same thing, that for the inner function g of x greater than 1, this is the domain of f of x. And if I look at the actual domain given for function f, which is x belongs to a real number, so this lies totally inside it, so it's fine. Composite function is existing. So let's find out now the range of the what? Composite function. What is the domain, by the way? Domain of the composite function will be x less than 2, right? We have seen that the domain of the composite function is the same as the domain of the first function or lies inside it. Okay, so now I am putting x greater than 1 in function f. And I have just explained to you reason here, because the range of g of x is the domain of f. So that's why I'm putting it here. And what did I get? Minus 4. Now why I'm taking greater than minus 4? Again, you can visualize the graph here. This is your linear function, x minus 5. Function f, x minus 5 is your linear function. So when I sketch it here, x minus 5, and I'm looking at the values of y for which the x is greater than 1, right? This is 1. So I'm talking about this part of the curve. So if I come here, this is the graph I'm talking about. So what are the values of y on it? The values of y on it are greater than minus 4. So that's why this gives me the range, right? And the second method, what did I tell you in the previous part? I just told you that you have to find the composite function first. I'm not doing it stepwise, I have explained it to you. And in this function, which value of x you will plug in now? You will plug in this value, this one, right? And the reason is because you have found the composite function first. So to get the image, you will find out, or you will substitute the domain of the first function. Got it? So third example, I'm not explaining, video will get longer, but I will show you the solution and you try to understand it yourself. If you have any question, you can ask me. So I'm keeping it on the screen for few minutes slowly. Exactly same method I have done. First of all, I have plug in this domain in function g, which is my inner function, and I got this range because it is a linear function. So I straight away substituted without any problem. And this is exactly the same as the domain of function f. Why? Because your range of first function become the domain of the second function. So it is exactly same. But now this was a quadratic equation. So that's why I did a sketch here first. Right? And I got my range of the composite function. You can put the video on pause and try it. If you have a question, you can write in the description below. And this is the second method. First I found the composite function and then I plug in the values in it. I will keep it on the screen for a few seconds so that you can visualize it and understand it better. Okay. Exactly same. So thank you very much for watching the video. You can share and subscribe. You can share it with your friend and subscribe it. Take care. Allah Hafiz.